So, on that problem number 1 on page 115, so in order to find the range, not the Randy, it's going to be 11 minus 10.1. So you just come out to 0.9 with the range. In order to find the IQR, just look on Desmos. Plug this information in on Desmos, and we can do more of that later. And then you're going to go Q3 minus Q1, and that's going to give you the IQR. So in this case, it should be 0.25. And then the standard deviation, again, we're using S at X. You could use just X or S, excuse me. If you plugged in Desmos, Desmos is going to find it pretty easily for you, okay? Explain the meaning of the range. Basically, it's where all your data falls. Your highest versus subtract your lowest. That's all it is. The IQR is the middle 50% of your data. So that's number 3. Number 4, sprint times deviate by an average of 2.09. So the standard deviation being 0.209, that just means that we deviate, like we go to the right or to the left of it that much from the mean, okay, or the expected value. If you plugged, you didn't even have to plug this one in, but number 5, the standard deviation is going to be 0 because they're all the exact same. If you plugged in the data points 1, 2, 3, and then 100, and you found the standard deviation, it's going to be 43.517. Again, Desmos will find it. What made that jump up to 43.517? What made it jump so high? Yeah, the 100. That was way out to the far right. Okay. But then the ones I wanted to hit upon. So 7, 8, and 9. So you have 2 different data sets. So data in number 2 has the greatest mean. And then number 8, number 2 has the greatest mean. And then number 9, you have the exact same mean. And then the standard deviation, again, this is what Desmos will do for you. This is tied. Okay, they have the same standard deviation between the 2 data sets. It doesn't mean they're broken. Number 1 has the largest standard deviation. And then on number 9, number 2 has the greatest standard deviation. Okay, so I showed you on Desmos. Does anyone need me to run through anything on Desmos? Do you feel comfortable with Desmos? Well, of course, we'll play around more with it, but I know we're on a shorter period, so let's hold off maybe until tomorrow, hit some Desmos stuff. Deal? All right. And then problem number 10, this is on 116. You have histograms identify the largest and smaller standard deviation. So if I were to count my graphs as 1, 2, 3, 4, 5, number 4 has the largest standard deviation, while this has the smallest. And the reason you know that 4 is the largest is you have basically data that looks like this. So because these 2 endpoints are so crazy high, that's wrong for the state of Colorado, crazy high. Sorry, service mind goes to weird places. Because those 2 endpoints are just high pillars and the rest is low, that's going to change the standard deviation. The reason why number 5 has the smallest standard deviation is you have this really nice looking curve with your graph. Okay, so this has a nice fluid look to it. So that's going to create the smallest standard deviation. The first graph and the third graph have, pulling to the left or right, depending on how you look at it. And then the second graph, the standard deviation is going to probably be the exact same, or very close to the exact same because all the pillars are the same. 11, a standard deviation 0. That just means you have the exact same observations. And then you cannot have a negative value for standard deviation because you are squaring each quantity and then you're taking the square root of the summed up quantity. So that's not going to, it always have to be positive. And then problem number 13. Hey, thanks, sir. Number 13, they want to know who is the best salesman, who is the most consistent. So Ben is the best. And I'll answer why these happen in a minute. Letter B, who is the most consistent? Ben is the most consistent. Letter C, who is the least consistent? Jerry. And then letter D, between Jerry and Thomas, which salesman is most likely to sell more than 2,000 in a given week? It's Jerry. All right, so what we're doing on any of those is, think about this. So Ben has a mean of 2,200 and a standard deviation of 600. Okay? Jerry has a mean of 1,700 and a standard deviation of 900. And then Thomas has a mean of 1,700 and a standard deviation of 700. Okay, so this is how you kind of have to look at it. Okay? Ben, if I were to do a normal curve, his average, his mean is right there in the middle. So this is Ben. And then a standard deviation goes out 600. So this goes to 2,800. What I did is I went plus 600. And then I go minus 600. And that's going to give me 1,600. Okay? So you kind of look at how far this standard deviation is from each other. And it looks like it spans 1,200 for Ben. Does that make sense how I just said that? Okay? So that's one thing to look at. Then so that's Ben. Let's look at Jerry. I'm going to draw a normal curve as well. And we haven't talked about normal curves yet, but this is what's basically happened. That's supposed to have a nice smooth thing to it. So that's 1,700. I add 900 this way. So that's going to take me out to 2,600. I believe I did my math right. Over this way, I'm going to subtract 900. And so that's going to give me 800. So the span between one standard deviation, 26 minus 800. Is that, how much is that? 26 minus 8 is 1,800. 1,800 span. So, and then Thomas, I think that's who it is. Thomas has also a normal distribution. So they're saying this is 1,700, and then we add 700 to get one standard deviation. That's 2,400. We subtract 700, so that takes me to 1,000. Thanks, sir. I'll take it. Perfect. Appreciate you. So this has a span of 1,400. Okay? And again, we haven't talked about normal curves a whole lot yet, but so how do you find that? Why do we say that Ben has the best? Well, one, you're looking at, he's doing 2,200 consistency, and he goes up to 2,800. He's got a span of 1,200. So standard deviation is closer to the mean than the other two, versus 1,400 and 1,800. And then it says, who is the most consistent salesman? Ben, again, is the most consistent salesman because the standard deviation, once we did that big old equation, we did it by hand, which makes you a really weird person, or if you did it on Desmos, it makes you a normal person. Because the standard deviation isn't spread wide, that means you're getting consistency out of the Ben. And then letter C, who is the least consistent? The least consistent salesperson has to be Jerry because his standard deviation is so wide. He could range from selling $800 a month all the way up to $2,600 a month. And this normal curve that we've drawn, we haven't really got, I'm basically showing you the very first picture. So that's why Jerry is the least consistent. And then between Thomas and Jerry, who is more likely to have a 2,000 on a given week? So they're saying Jerry, if we compare the blue and the black normal curves, why would I say Jerry? 2000 is 300 to the right, 300 to the right. Oh, okay. Because Jerry has a bigger span to the right, it's more likely to take place. So what I want to do is let me build off this normal curve a little bit so it makes a little bit more sense. And then we'll get into the next lecture tomorrow, if that's okay. Okay, so this is called a normal curve. Okay, and I'm pre-showing you this. So underneath this normal curve, there is an area. The area will get to 100%. 100% as not a 9% is 1. Okay, so the area under the normal curve. This is the x-axis, but you notice I have a tail and a tail. What do you kind of notice about the tail with my drawing? And it's not because, well, my drawing is already kind of cruddy, but what do you notice about the tail? It gets smaller as it goes to the right and to the left, I agree. What do you notice about the tail on either side with represented the x-axis? It's starting to get parallel. It's coming down. I love the terminology. What's happening, if any of you have taken pre-calculus, the x-axis becomes a limit because you approach it, you don't touch it. So that's what it's really taking place. Now, other things with this is this pink bar here. This is going to be the mean. This is the average. And the average and the mean also mean what? Expected value. Okay. So if I go out one standard deviation to the right, or if I go out one standard deviation to the left, and I'm making it positive, negative, just so it can indicate a direction. This region here is 34% of the area, and this region here is 34% of the area, which means this red region here accounts for 68% of your information as far as a normal curve would go. Okay? So with that known, can you go out 2 standard deviations? Yes. 3, yes. 4, yes. 5, yes. The further and further and further you go out to the right and to the left, the closer and closer and closer you get to the area of 1 or the percentage of 100%. Theoretically, you should never get exactly to 1 or exactly to 100% with a normal curve because those tails are approaching the x-axis. So in theory, if you had some standard deviation and some normal curve, if they were to say, what is the area of the entire normal curve? Well, the entire normal curve means you're going to infinity both ways, which gets you to 100%. But you're approaching 100% as far as the area under the curve goes. So as we progress further and further in this class, we have the expected value that we're going to start referring to more and more as the mean. The expected value means that we are, hey, what's my expected value? And then we're going to say within 1 standard deviation. So you're at 68% of your events that would take place would fall within 1 standard deviation. We don't know what the standard deviation is right now. I'm labeling it as 1 and -1. If I did that, that means that the mean would be 0. Okay? But obviously, we have had information that we've used where we have a mean that's something that's not 0. We have something that's a standard deviation that is not 1. But as far as our information goes, the area underneath the curve is what we're dealing with. And what our whole gist of this class will be is what is the area that we're finding? Okay, some percent. And then this either goes to the left or to the right. What is the x-axis value? Okay, and then obviously the things that we will look for is if it says normal distribution, is great to see in your reading, but also a random, I'm just going to say random sample. It's actually called a random stratified sample, but I'm not going to write stratified. This is stuff that you don't need to know, but this is what we're approaching. So things that we will get to would be like this. We could get to, saying, hey, I got this point right here. So this point right here refers to a certain area here, which starts becoming the probability that that event takes place. Okay? Percentiles and standard deviations go hand in hand, but the percentile doesn't always mean, your standard deviation, or excuse me, your mean is going to be a certain value. Your mean on a normal distribution would be at the 50th percentile. Even though your mean, let's say your mean is like 38. So if your mean was 38 on a normal distribution, the mean is at the 50th percentile, meaning that the median and the mean are the same because they fall on the that portion of the graph. Okay, so this is all kind of big meat and potatoes of the class. I had only 10 minutes left, which is not enough for me to roll into the next section, which is fine. But those are just a few things that we are aiming towards. We are not mastering this at this point. We're just aiming towards getting here. And it starts getting kind of strange, but things that my goal by May, when we're done with this class, I want you to realize when you're given information, call nuh-uh on it. Yeah, that's the official term. Nuh-uh, yeah-huh. Right? Whoever says nuh-uh or yeah-huh last wins the argument. So when I go through, anytime somebody is presenting information to me, if they start throwing percents at me, if they start giving me any type of averages, anything like that, I am saying bull poop right away because it doesn't mean anything. I can come out with the greatest conversation, and I kid you not, my wife always gets mad at me. My wife also doesn't let me talk to people. So I know I can't go to the mall because I buy too many shoes, and I also get in people's way. I can't go to the grocery store because I grab the gross items off the shelves and put it in people's carts. I also I look for the guy who thinks he's extra special, like he's all that. I grab the Depends undergarments, put them in his shopping cart. So my wife doesn't invite me, but she also doesn't allow me to talk to people when they start spewing data and statistics, because I'll usually spew stats right back at them like it means something. It's like, someone will come tell me about how good their service and provide and what they've shown. And I'll say, really? I realize that 28% of the people that live in this neighborhood, only 16% of them actually fall into this particular category. And if that's 16%, another 19% of them fall into this category. And they're like, yeah, see, like I told you. It's like, I just made everything up. And this guy who's trying to sell me something is now agreeing with me because I just spewed percents that mean nothing. I make it all up. And my wife's like, would you quit doing that to people? It's like, it's kind of fun. I know people should have jobs. My biggest battle this summer. There's a new fiber optic company in the area, perhaps it's come through your neighborhood, called Ting. Have you seen these people yet? So my first thing with Ting is that they have this drilling company, drilling for oil, it looks like, but they're doing these horizontal drills across people's yards to put their fiber optic cable. So I asked him, I said, hey, what's going on? It's like, oh, we have permission to be in your neighborhood. I didn't ask you that. I said, what are you guys doing? So we're putting a high-speed fiber optic. You were notified. No, I wasn't. And none of my neighbors were. I said, okay, but still, you're within the easement. I was just asking what you're doing. So then they cut my Comcast line And so I walked outside and said, hey, you guys cut our Comcast line. My wife is a teacher teaching an online class for CU Denver right now, and you cut the line. Well, like, well, that's not our problem. I said, well, did you call Comcast to let them know you cut the line? They're like, well, no. So I called Comcast because they knocked out pretty much everyone up and down my street who was on Comcast. Comcast sent 30 people out to fix the error they did. So then my summer consists of me, I'm way too bored, so my wife's always saying, you got to get back to teaching because I'm too bored. So I go out and I ride my bike every day. I usually ride about 15 to 20 miles, and then I wind up at my gym, stretch, hit some weights, get back on my bike, ride home. That's my day, which is great. I love it, but it's also my day because I'm bored. I'm riding down Clarkson right about Mineral Way, which is in my neighborhood. And this same drilling company, all of a sudden I see, boom! And I turn around and there's 4 guys that are like laid out. They went right through an electric main. So everyone's okay. No one was killed, fortunately. So I go and I talk to them. I said, guys, you're drilling, but I don't see anything marked. They're like, oh, we know where all the lines are. I kid you not. Okay? So if I dig in my backyard because I want to plant a tree, I need to dial 811. They have to come out and spray paint my yard and put flags down. So these guys are kind of ignoring me. So I call the company who is the drilling company, and they treat me like I don't know what I'm doing. Well, I have 10 weeks off, so I got time. So then I called the company Ting, and I said, hey, I just need you to know that this company who's putting your fiber optics is making your company look horrible. And he's like, oh, no, you have to understand our internet, blah, blah, blah. And I said, oh, now you're spewing data to me. I'm like, well, that's funny because I have Comcast. My Comcast will run 68% faster on an afternoon when 97% of my neighbors are online. He's like, well, yeah. So now I've kind of lied to him, but he agreed with me. So then I come home from school or come home from riding, and they have this big tractor sitting in my front yard, huge treaded tractor. Now, the other part of my summer is I love to garden and I love to have my yard look nice. Now I have treaded tracks in my yard beyond the easement. I'm talking about 25 feet into my yard. The easement's 3.5 feet. I know this because that's where the gas line is. Gas line is where the easement takes place, which utilities can go into. So they're like, we have the right to be here. You don't have the right to be in my yard. You're tearing up my yard. And then I look over at my neighbor's yard, and there's about 30 or 40 of the workers having a picnic in my neighbor's front yard sitting under his tree. I'm like, this is ridiculous. So then I called City of Centennial. I said, I need to complain about this company Ting and Rocky Mountain Drilling who's doing all this stuff. So like, letting me put you on with the city manager. City manager gets on, and he's like, this is the biggest pain in the you-know-what that I've ever had to deal with, this company. So then I said, I need you to come out and see the damage that they've done to my yard and to my street. So the two city managers come to my house. The vice president of Ting comes to my house, and the owners of the drilling company come to my house. I start pointing out these problems. And I said, well, you know, they cut the first thing that really set me off, so they cut the cable line. And City of Centennial's got an iPad. They said, when was that? And I tell them. They never reported that they cut a utility line. The drilling company fined $25,000. They never reported that they cut an electric main, $25,000 fine. We have humps throughout my neighborhood because when they were supposed to bore under roads, they were supposed to go down 6 feet and then traverse under the road and come up. They went right under it. They had to repave my entire neighborhood. Because of all this damage, there was a 30-day cease and assist order. They could do zero work in my neighborhood. And the vice president of Ting is looking at me. I'm like, yeah, you messed with the bull. And I won. And I'll tell you what, and the guy from Ting is like, what can I do to make this right for you? I said, you see that big orange fiber optic cable? I said, yeah. I said, you go stick it where the sun don't shine. And City and Centennial's like, writing tickets to these people. So, but now you just kind of got a little phase into stirrup, because you come at me with data and statistics, I'm going to come at you with data and statistics. It's all fabricated. Peace out, friends. Be good. Have a great day. Take care of one another. And